how to use or more of practical sessions that we are looking at. So I think in Kubernetes process we learned many things. So I'm now applying all these concepts that we learned in some examples. So in this process, I think if you remember in the last session we did a hello world web application, and this time let's go to a bit complex application and try to set up this on GKE. So typically in any I mean, most of your applications in enterprise will have a multi-tier setup. So, so for a multi-tier setup, let's assume that you have a multi-tier setup where there is a front end and there is a back end, so in that case, how will you configure that in Kubernetes? So that is what we are trying to see in this example today. So probably the logical steps before going, like there will be a UI component which is developed on PHP, and there's a UI talking to a uh, to a DB. So I'm just keeping it very simple. I mean, you're talking to a DB. DB is it's not really DB here. It is Redis. It can consider Redis as a DB. It's more of a caching DB. So it caches everything. So this is the architecture that we are looking at. So it is slightly complex than what we saw the hello world example that we saw in the last session. So it is just an extension of that. So if you take this, I think we already looked at all the steps, but I think it's more there's a UI component and there's a DB component. So one thing which we need to know from design perspective is when you have multiple components like this, the Kubernetes service that we deploy, the Kubernetes service will the type matters here. The type, if you remember, we discussed the load balancer, and if you don't mention anything, it will come as cluster IP. So these are the two types for service. So UI component has to be generally UI is a front of the application. So UI need to be accessed worldwide or from the world. So that's why in a UI we have a load balancer service. But this DB generally you will not expose it to outside world. So that's why you need cluster IP in this case. So which means when you say DB as cluster type, so which means that you will you are basically telling this DB IPs will be accessible within the cluster but not outside. So not a common man outside can't access this because it is within the cluster boundary. So basically that localization aspect. So this cluster IP will hide the IP addresses from accessing from outside. Whereas UI will be having type load balancer, which means it can be accessed from outside. That's the only difference. So that is something you need to keep in mind when you design the multi-layer setup. So let's go back to this. So this architecture. So this is what we're trying to set up. This I think we discussed at a high level in the last session, but this is a load balancer, and load balancer is actually using GKE. It is calling the front end service. So front end service is developed in PHP. This front end service is actually talking to the DB layer. This is all there's a DB layer. So this DB layer will have again for backup purposes. We thought there will always a leader and there's a follower. So in case leader is dying or dies, so there will be a follower will become the leader. So it's more of a high availability case. So but at the end you can think this is a UI and the DB. That's all. There's nothing else there. So but we are just this leader follower is just primary secondary stuff. So that is the architecture that we're going to look at. So yeah, and so probably let's go in. So I'll directly get into this component. I mean, any questions before we jump in? I just prepared the list of steps so that it's easy. Yes. So first thing, as usual, I'll just close this so that you see it from front. So as usual, Kubernetes GKE is what in cluster. A cluster is empty right now. Doesn't have anything. Since we usually go create the cluster, but this time I'm taking a different step where I create the cluster and nodes also through command line. So far we're creating it from the UI and then connecting to the cluster. But I mean, all cloud vendors, they have this option of creating this cluster also through CLI. So I'm not directly going to the CLI Cloud Shell. So okay, so just open the previous session. So I cleared it. Okay, so I'm in this session. So the initial steps would be, of course, you need to go and create, set the config. This is you're setting this project to our project config. So I mean, just to show you, this project config is this my project, which is already there, and this is my ID, this Team Spider. So this is my project ID. So I need to set the context to this project ID first. So for that, I need to use this gcloud. Gcloud is a CLI for Google Cloud. So anything gcloud is like you're talking to a command line of GCP. So gcloud config, set project, and the project name. So that should be the first step. So this is, it's already set, but I'm just ran it again because you can see this is already set to this instance. And then second is you should set the, again you're instructing all the resources that you want to create in this. You want to set a compute zone. So in this, I'm setting this as US West A. So this is again a zone, so you can select which zone you want. I'm selecting US West 1A. So with this, now at this point I have set up the CLI config properties. So the project ID is this, and my zone is this. So with that, now I can start using GK specific stuff. So in this process, I want to create a 4-node cluster. So the default is 3, but I want to create a 4-node cluster. So here gcloud, again container clusters. So this is the command. Container clusters is for GKE cluster. So container cluster and create whatever is the name of the cluster. So and then num nodes is equal to 4. So this is basically it is creating a cluster with the name as guestbook and nodes as 4. So it will take some time. Well, just at least a couple of minutes. But if you look at it is actually at this process it will creating 4 nodes, so which means it creates a master and also it creates 4 nodes which are acting as a worker nodes, and also this is all creating in a region US West 1A which you already said. So after this, let this run. In a minute, let's go back, take a test for a couple of minutes. So let's come to this process. In this first thing is generally we will do the deployment. So we generally do the Redis deployment. First thing is I want to go in a serial order. First, I want to create the backends first, because generally when you do a deployment, fresh deployment, you start with the backend, deploy the backend, and then you deploy finally the frontend. So that when frontend talks to backend, you have the backend available already. So first you need to deploy the backend. So again, in this backend, we have a leader service and a follower service. So this is what we want to do. So this leader, any component in Kubernetes, of course, we have 2 things: deployments and service. So deployments will give you the view of the pods that you want to create, and service is exposing the endpoints. So the networking piece. So let's start with the leader. So let's create a deployment first. So in Kubernetes, the deployment is you give a kind as deployment. Of course, these are all standard metadata that you can give whatever name you want, but it should be logical. So the name in this case is Redis leader, and labels are app, role, tire. You can also give whatever you want. It's easy for you to identify this pod at any given time. So you can give any name. So but logical here, the role is leader, and also the tire it's a backend part. So tire is backend. And under spec, if you remember spec, we have 3 sections: RST. R stands for replicas, S stands for selector, and T stands for template. So RSD, that R is like replicas, number of replicas, how many you want? One. I'm just keeping it one replica. And selector is yeah. So again, match labels app Redis. So whenever you want to increment it, so you use this. It uses match labels as a reference. So when you want to increment this with this replicas by 2, so this labels matters. So that's why it is important to use the labels correctly. And RSDT is template. Template again, template will have the metadata section again. And spec is one is important. So the spec will have the actual Docker image or the container or image that you want to deploy. So since we are going to deploy Redis is standard image in Docker site. So you can download, yeah, from Docker Hub. This will be downloaded. So and of course we are especially this column is for version name. So you're giving 605, which means yeah. So this version 6.0.5 will be downloaded. So and also in this process we are also giving the request CPU and memory and container port, which is the default is Redis. The default container port is 6379. So if you want to change that, you can change that here, but we are just going with the default. Yeah, so this is what we are going to create deployment. So let's see this is still running. Let's go to service part also. So the deployment will actually create the pods. So basically, once you run this command, it will create, and then when you do a get pods, it will fetch the. It will just create one instance of Redis reader. So and then when you do a logs, you can see that log stuff. So the next is service. So service, you need to same thing. Redis, any component we have a deployment and a service. The service component is the one which is actually giving the IP or bringing a networking aspect to this. So it is associating a IP address so that you can access this Redis component. So basically at this point the pod is what is deployed. So you can see this pod, but you want to access this pod, then you need a service. So service is what we will create using this service component. So again, the kind here will be service, the standard metadata, and the spec is important. Ports here is where we tell what ports and selectors. So these are two things that we need for creating this. Okay, so this is done. So here, if you look at it, finally printed. This is the cluster name, which is guestbook, and US West 1A, and master version, which is 1.18.16. This is a Kubernetes version deployed for master, and the master IP is this, and the machine type is E2 medium, and the node version is also same like master, and the number of nodes are 4. So you can see the same thing from console also. Initially it is empty, right? So here we can see some clusters now listed. Okay, I've created a guestbook. So if we go here, in this guestbook you will see all the details of the cluster, which is US West, and this is an endpoint ID that is created. Yeah, it defaulted many things, many parameters, but you can also enable them anytime. So, and of course the nodes, so it's a 4-node cluster. So we need 4 nodes, and these are the 4 nodes that were created. So these are the virtual machines basically. The nodes are running with 4 virtual machines formed as one cluster. And of course, there are some default CPU memory allocated for these nodes. So yeah, so that is about this part. Because it the storage part. Storage also it defaulted. So there's no persistent volumes. We'll discuss about persistent volumes. This is the one interesting topic. So where you can also so far we could create nodes, but with persistent volumes you can also create associated storage also to a cluster. So that we'll see when we go to the persistent volumes Kubernetes objects. But of course, logs is where you can see the logs of all the cluster that is created. If you face any issues, you can go and check here. So it created all the printing all the logs for you from server. Okay, so that's about cluster. So at this point, we just create a Kubernetes cluster with 4 nodes. So now let's go to the deployment part. So we saw now we want to deploy the Redis reader, but before that, there are some commands, the cluster commands that also you can use. For example, this command will, again, this is again gcloud command, nothing to do with Kubernetes. The gcloud command, container cluster list, will list the containers. So list the container details about, again, whatever we saw here. The same thing, you can also get this using this command, gcloud container cluster list. Again, this one, again, we want to get more inputs about the cluster that we created. The cluster name is guestbook. So if you want to get more details, there's a describe command that you can use, which will describe more details about your cluster. So, as you can see from the UI also, so this will fetch a lot of information about, to describe more information about the cluster that you created. So, for example, it gives a lot of info in terms of in terms of what is your cluster IP, IPv4 address, what is your GKE, the Kubernetes version that is deployed in master, master, and it has also gives details about the instant cluster information, version, IP policies. What are we can associate a lot of policies. I think we'll see that Kubernetes policies as a separate section. So you can associate these policies also within this cluster creation. Some advanced concepts, but what is a certificate? So you need a cluster certificate that you need to create. So it creates a default cluster certificate for you. So these are some things which cloud automates to this stuff. If you have to do this manually, it have to take a lot of, it takes some time. Speaking the cluster itself is a bigger one. The network config, so it reduces the networking stuff by default. It tells you what is the network and what is subnet. So net and subnet details are also provided. And also it gives the node information also, the size, the disk size, and the type details. Of course, it also is giving default authorization for other Google APIs. So that you could access the monitoring part, you could access the log part, you also have the logs, right? So we need to provide approvals or authentications for all these things so that you could access them, part of the Unity stuff. So, and node pools. So node pools are cluster of nodes. It's called node pools. The node pools information, like again nodes size and other stuff. Location US West, and I think most of it is all normal stuff. So so basically you can get all this information here. So that's about the cluster summary. So far we created a cluster with 4 nodes. That was the task achieved. Now let's go to the Redis setup. So we have the infrastructure ready for Kubernetes. So we have master, and there's a 4 nodes, and now you need to give instructions to the master so that the master will make use of these 4 nodes and deploy your backend layer into the nodes. So that is the step that we're going to see. So this first thing is, of course, we just discussed, we're going to set up the Redis reader now. The reader is basically to use Redis to store its data, we just discussed, and first step is to deploy a Redis reader. So I think we already there's a Git clone that you can also download this stuff, which I already downloaded. So this again, same code whatever we saw here in this document is already there in this Google GitHub site as well. So you can download from here as well. I'm doing Git clone here and downloading that code, but which basically downloads this code. Samples gets book, and in that what we are going to do deploy is the deploy, right? So basically we're going to do the deployment. So Redis reader deployment. So this is the one which we're going to run it. Yeah. So this is the what basically I think what it basically now downloads this Docker image, Redis Docker image, and it will run it on 637. Okay. So let's run this step. Let's go here. think the script code, I think already will be there. I'm already in the folder. Okay. So here I'm just removing this stuff. So it's already there, so I'll just add it directly. Okay. So I'll get on this. See to this folder. And yeah, before running the deployment, let's run the script to get pods. It will list the pods. This will not be any output because we not create anything yet. So there's no resources found. So this is basically we just want to show it before and after. So now we're going to create that Redis leader deployment that we saw. So the kubectl again from here is actually we are starting the Kubernetes commands. So far we use our G-Cloud commands prior. So but really now we are actually now using kubectl command. Basically we are now applying. We're talking to the Kubernetes master and telling Kubernetes master by using this kubectl command and asking to apply this YAML file. This YAML file is what we just now saw, which is basically is trying to deploy this Redis leader and the container that is going to create is ready. Creating this apply -f. So it is now created. Now if I just go to get pods, it created that Redis leader. So earlier we saw there is no resources. When we put this kubectl, no resources. Now we have one resource, which is leader. So it is still status is container creating, which means it is still working. It is still not done yet. So let's run it again. Now it is running. So status is now running. So which means it is working. Otherwise, if there's error, it will say it is error. So now we of course we get the logs. It will get logs and then the resource. So basically, this is the log of the Redis that is created. So here, this is the important command. It says ready to accept the connection. So which means the Redis is good to accept. The Redis is nothing but a backend, right? So it is now ready to accept the connections for this. So which means it's all good. So now let's move to the. So we're done. So we're done with the deployment. So next thing is we also need to create a service. So again, service Redis service is here. So here Redis service we are just this is a service which means the type that will be applicable, but if you look at, there is no type here. So if you're not mentioning type, then cluster IP will be the default type. So we don't want to expose this backend layer to outside world. So that's why we are selecting the type as we're not giving any type, which means the default is cluster IP. So we're going to now run this. So basically, what this service does is it creates it applies the port. It's pure networking component. Service is a networking component. So it enables the port on 6379 on the target port, which is 6379. Again, we use the same, but it also can change the port. So basically, you're enabling the connections to accept the connections on this port going forward. So anyone when you run this, you can now access this Redis component using the IP address and this port. So far we couldn't access the IP address and port, so that is not possible. But with this command, by executing the service, you could now access the Redis with the IP and port. So basically, it is giving you an IP and port so you could access over the network. So it's pure networking component. So that's what we're going to do now. So kubectl same for service, same command apply -f. So let it read a service. The service is created. Now if we do get service, you should be able to see the cluster IP here. So we see a external IP will not be there. It is none. But whereas if you create a type as load balancer, you have an external IP associated. But for cluster IP, there is no external IP. It is an internal component. So basically, this IP address is accessible within this cluster, but not outside. And the port is what I mean. This is a default. This one is Kubernetes. This is always there, but the one that you created now is this. So the cluster IP, and this is the 219 is the IP address that is the same, and port is 379, which you already asked. So that's about this. You can also provide more information about it. So if you look at the selectors that we created, again, this one is our component. So the selectors, what you gave here, app, role is a leader, and tire is a backend. These are stuff that you link here. So this is what it has come here. Yeah, so the selector is what is important because it is possible that the same name could be also be there with, for a different application. By chance, it's not normal, but generally for in a Kubernetes cluster, there will be multiple projects they will be deploying their pods. So it is very well possible that the same name could be by mistake it will be taken. But what differentiates it is the selectors. The selectors at least should be unique, so that way, so that way it doesn't clash. So yeah. So yeah. So let's go back. So that's about the service. If you look at type is cluster IP, which is the default, and cluster IP is single IP for each set of the pods that service is pointing to, and IP is accessible only within the cluster. So we discussed. Now that's about the master. So Redis master is done. Now let's get the Redis follower. Follower is a backup to master. So let's look at the followers deployment. Here also same thing, follower deployment and service. So follower deployment. Only difference is here instead of follower will be there wherever we have earlier here it was to have leader. So that is one difference. So of course, another difference is the Docker image. So these are the only two differences. So yeah, and then we are running this on reports are all same. Yeah, and one important thing which I forgot to discuss is the resources. Yeah, this is. I will touch upon this resources when we go, but I think this is one important aspect where I want to share some story around this where it created a lot of impact for Arun. Arun, who is there in this call, who joins. They're using Kubernetes already, so for their projects, and he had some issues with which I think we were discussing last week. How to resolve some issues around this. But anyway, we'll come back to that. But this is something it gives you the CPU and memory for this container. Anyway, we'll come back to this section. But yeah, so now we are actually deploying this deployment for follower. So follower, same stuff. Kubectl deploy follower. Follower get service. This service, if you look at now, follower is also there added. Earlier before leader was there, now follower is also added. And again, same thing. So the IP is 225. No external IP here. Okay. So now two components are there for backend. So we are done with the backend. So basically we have one leader component and there's a follower component. So and yeah, and additional information. Role is follower and role is leader. Okay, so now now let's now go to the front end part. So we are done with the back end. So let's go to the front. Front end is nothing but is a guestbook app, which is a PHP front end. So which communicates with either Redis follower or a leader. So yeah, it depends on where the load is more. So there are two Redis components now, a leader and there's a follower. So when you hit from a UI, the call will either go to the follower or a leader based on whichever is available in field. But both are running at this point. So depending on whether the request is a read or a write. So that is also another combination that we can write in the logic of the code. So leader will be probably used for writing something, and a follower could be used to read something. So that's also one of the different things. So but anyway, I'm looking on this, open this front end component now. So we're done with the back end. Now we're trying to create the same thing, deployment and service for front end. So the front end is this. Again, so Candice deployment. And the replicas here we are trying to create is three. We're creating three replicas here. Again, RST, replicas, selectors, templates. Selector will have match labels, and template will have MS. T will have MS. And that's how I remember RST, MS. So replica, selector, template, and MS is metadata spec. So RSTMS. So yeah, again, this is a front end component. That's why we're mentioning as front end, but the app is same guestbook. So and here the container under spec is we are now going to use. It's a PHP application. So and this image for this front end, which is a PHP based application, already uploaded to. It's already an image is already there in the GCF container registry. So and then we are with the version 5 is what is the latest version. So yeah, so we are going to, this image is already available. So this Kubernetes is going to download, pull this image, and then set up this application. So in our case, let's say you have a Angular or a React application, probably you have to deploy this as a create this container image for an Angular or a React application and put it into container registry and give that container registry link here. So yeah, again, what is different is this. This one, environment. So environment is actually, it is asking, they're giving the value as DNS, which means whenever this front end has to call the backend, which is the Redis components, when we have, this here is the Redis components, we have our Redis name, which is the Redis follower, and here it is Redis leader. So, and the service components are again same thing, Redis leader and Redis follower. So when front end has to call the backend, it is not a good idea to use IP address because IP address can change. So basically we are. So then how can a front end can call the backend? So that's where the DNS part will come. So what will be the DNS that front end should use to call the backend? So the DNS part, either you can use sample values DNS, which means it will by default use the DNS name, which is for the backends. So that's how DNS. So basically, when front end is trying to call the backend, it will use the front end names, the backend names of this. That's how it associates to the respective IP addresses of the backend. So yeah, so this is I trying primarily get host from will give inputs for DNS mapping. And of course, the port here is the web application, so port will be 80. 80 is the default web port. So that's what we're using here. Okay, so let's try to deploy this command. Now let's deploy this front end. And yeah, here I'm doing get pods. Of course, this get pods, if I give, it will fetch many records, but not many here. But you can also filter with the still container creating, which means it is still creating. It creates, since we mentioned as 3 replicas here. So it's creating 3 replicas of the front end. But still in container creating state, which means it is still working on it. Which is still running. Yeah, running. So we have 3. So imagine in bigger projects, right, there will be multiple pods will be deployed because the Kubernetes will multiple projects will use the same Kubernetes clusters. So how can you filter this? Because here we have four, so it's easy. But imagine in multiple projects there will be hundreds of pods. So how can you deploy? How can you filter that? So this filter criteria is using -L. So -L will by the way, here you can view the labels that you created. So the labels is where again now coming as a handy to filter stuff. The labels, if you remember, that we created while creating a deployment, the labels here is this guestbook, tire is frontend. So we are now using applicable to guestbook and tire is input frontend. So this will help you to filter the records. In our case, it's not relevant, but this is giving you as an additional input. So you can. So basically, this should not fetch the backend part now. So it should only fetch the front end. Yeah. So just fetching only the front end. That's how we filter the get parts output. Okay. So yeah, and here, yeah, one important thing which I forgot to mention is I think we discussed about the DNS, but yeah, this also we look at the we're done with the deployment, right? Okay, we're not done with service yet. So okay, so let's deploy the service, but let's move on the service. So if you look at the service this is uh, service again type see we mentioned as load balancer. Again we discussed so the front end application requires people to be accessing using some static IP. So you want to give static IP in this case, which shouldn't change. So in that case you need to while creating service you will mention this type as load balancer. Whereas in other place you didn't mention any type, which means by default cluster IP will be created, which means access the backend is accessed within the cluster. Let's move on here. So now let's create the service. Yeah, that's what I mentioned here. Manifest we discussed about DNS, and also when you provide the configuration to guestbook web frontend, the frontend application uses the host name Redis follower and Redis. Yeah, I'm talking about this DNS now. So when frontend is trying to access the backend, since we give the get host from DNS, so it will use the host name as this. It will not use IP address, so it will use the IP address as the host name, which is Redis follower and Redis reader. That's how frontend will access the backend. So that's why also to perform the DNS lookup in this process. And DNS lookup is also another feature within Kubernetes, which is implicitly available. So since IP addresses are always can change, so Kubernetes gives an advantage of DNS lookup. So DNS lookup, because DNS lookup is nothing but when you want to hit an API using curl or from the front end you want to access the backend API. So the IP address and host, the host and the port. So that should be resolved by DNS. So that lookup will be taken care by the Kubernetes. So Kubernetes has an implicit DNS service discovery. So that will help you to identify or translate this DNS name to the respective IP behind the scenes. So DNS lookup finds the IP address of the respective services we created in the previous step. So this concept is called DNS service discovery. So that one other headache that you need to take care is also taken care in Kubernetes. So DNS, how frontend can call a backend. So how should be the IP address? Don't worry, use the host name itself. So that will be automatically mapped. Yes, so let's come back to this service now. So we're done with the deployment of the front end. Now we're going to deploy the service here. Okay, service front end, get service front end. Okay, here still it is pending. This is we type as external. The type here is load balancer, so we can get an external IP here. So this is how once you get this IP, we will use this IP to access the front end application, the front end part of which is called the PHP. So let's yeah. So yeah, I think one important thing we already discussed, and when you another one is we are omitting the target port here. You see here. Port is only mentioned, but of course you can also give a target port. For example, if you see here, you mentioned target port here. So But here in this is a leaders service, but in the front end service, we just mentioned port, we didn't mention target port. So what does that mean is basically it will omit if you're not giving the target port, by default it will take the value of port. So port and target port will both 80 in this case. And if you don't mention target port, by default it will take port, which is onboard port itself as a target port. So yes, so let's check this. It's created. External guides. Now there external has come. So this is a load balancer which is created now. So now we can invoke this load balancer IP to access the front end. So let's let the load balancer. So this is our UI application. UI is up. So this is a simple front end. So I'll just put submit. But we got some idea. I think these are the high-level steps. So yeah, there are some additional commands which we can also probably want to replicate the instances. So currently we have, for example, get pods when you run. So there are 3 front-end instances. So let's say due to scaling requirements, you want to increase scalar. So you can also scale up this instances to 5. So yeah, what are number for example? So you can use this little scale command. So it will increase your instances to 5. So just giving to scale this variables to 5. So then it will get 4 here. So this will increase the instances to so 3 front ends. Now we have 5 front ends. So the scaling is that easy. So just simply command. And also get what. So of course, yeah, that's about it. So you can just of course clean this stuff and don't want to clean. So you don't want to don't delete this. You can keep it in delete service. It's also always there, and you can also delete the entire Kubernetes nodes, which I don't do now, but yeah, it has some commands to do that. Again, I'm not sure why this is not. I'm just giving you a random for this to see if it works. I think it should show here. Actually, the name should be listed here. Anyway, not sure. I think some problem in probably talking the front end talking to the back end. See the logs. Okay, follow is not there. This some step. Follow is what? That's the problem. So you don't have any different. I think it's this followers. Um, so research step. So okay. So yeah, basically now actually what happened is the front end I missed to create the follower step. So because of which probably the front end is trying to use the follower as a DNS, which it couldn't find. So they missed that step. So now with that now it is working. So yeah, that's output. So simple web application which is a front end talking to a database. The database is Redis in this case. Okay, so that's about this. Any questions here?
Yeah, this kind of troubleshooting is also very helpful for the exam.
Yeah. Yeah, I think mostly the information is the source is your logs. Um, more I mean, unless you see, mostly the logs will give you some inputs. Also, you can refer I mean, you can also use the describe commands, which will also give you some additional information. For example, this kubectl describe pods will also give you some additional information. I'm sure I'm going to comment that. So yeah, so this Kubernetes describe pods will also give this event section will be very helpful to identify something is failed. This event will give you that information. That is describe commands. If you see the describe will give you all the information about. It will give you a lot of info, but I think probably you should filter what you want. But this is giving the information of all the pods that are created. Okay, this is our starting point. Right? Okay. If you look at this is front end pod, so the history of the front end pod information, and uh, uh, and also this here if there is any error, so you get the errors in the events. So something is not created. What was the issue, right? So this message will be very handy to help. So yeah, so in case there's an error, it will tell you state reason will be error, and it will also give the information what is the message. Because we have 5 instances of front end, so this is a second front end. So, so which is third front end, fourth one, fifth one, and of course we have the back end stuff, uh, the pods, the Redis stuff, Redis follower, and uh, Redis front end, Redis leader. So yeah, so these are the various steps that you could also use. Okay, so any questions before we move to the next topic? So you got a perspective now, I guess. I mean, assuming that we have a multi-tier, then how to handle. So every component, every tier will have a deployment component and a service component. So you need to deploy both. Prerequisite is for deployment to work, you should have your image. This is a standard image, so that is that can download from Docker Hub directly. But if you have a custom image, your own application that you develop, so instead of a jar file or a exe file, in Kubernetes world, you need to give a image, Docker image. So you need to host this Docker image somewhere, so this can be accessible. So that is a prerequisite. So yeah. Yeah, so I was discussing about this resources section. Right? I think this is a very interesting use case. So uh, the problem statement with Arun, probably Arun once he comes, probably joins in the next session. So probably he can give more inputs. Um, so the problem statement with regard to CPU memory was actually they were creating a Kubernetes object, and he has a front end developed in Angular. And this and also the backend also is there, which is developed in Spring Boot Java application. So UI layer talking to a Spring Boot backend layer. So in this process, its backend layer is a bit heavy. But he's given less CPU and memory for it. So what happened is when the users are the user suddenly users spiked up for this backend, so and a lot of people started using it, and suddenly it couldn't accept some connections. So they couldn't. When there is one, actually the issue is basically the API is actually making a DB call, and the DB is also having less CPU and memory, because of which when the spike increased, it couldn't handle the load. So where I'm trying to come here is this CPU memory is something you need to do some planning before you need to understand your code, you need to understand your users and the traffic, and based on that you need to come up with the number. Of course, this you can change anytime, anytime. But the only thing is, just avoid some downtimes like the spike up scenarios. It's always good to plan things and then deploy it, not just putting a random number here. Yeah, that's something you should also take care. Right. Okay. So let's move on to the different topic. Which is a third topic, which is I think we saw the first two, which is a simple hello world, and we saw a guest book, which is a Redis and PHP front end back end. Now let's look at the third case, which is a disk storage. So this is an interesting use case. Probably considering the time, yeah, let's try to look at the concept first. Probably time permits, we'll do it in the next session, the practicals. But before that, we need to understand a few things, which is I don't have slides, but I will try to prepare slides for the next session. But what we need to understand some basic concepts like uh, for storage, right? I mean, we're talking about the storage. So generally, Kubernetes is a perfect application for um, for non-persistent systems, like non-persistent meaning no DB scenario. So it will be perfect fit. But most of the applications require a DB, right? So which means the DB comes along with storage also. So you need to uh, uh, the DB should store the data in some storage. And now, as you know, everything in Kubernetes is a pod. So DB also is a pod. So, but what we learned from Kubernetes is that pod state can change. It can die down anytime. So pod is like it can anytime it can die. So it's ephemeral. So which means the DB also can die, right? So the DB as a pod. So let's say MySQL as a pod. So let's say you want to have MySQL as a DB. So you create a MySQL pod. But this pod also can die. So which means the IP address when it comes back again, the IP address will change. So in that case, it is good in UI component. That's even if it dies doesn't matter. But in a DB, if it dies, then it matters because the data is lost. Right? So how to handle something going to crash? Then in DB, you need to store the state. So when some pod crashes, you need to store the state of the DB. So store the state of the DB so that when it comes back, when a new pod is created, so it can fetch the data from the state that was persisted. So this is the concept. So I mean, wherever you need a persistent state persistence, so that's where you need to use a Kubernetes concepts called with our deployment service, something called other Kubernetes objects like persistent volume and persistent claim. So these are two Kubernetes objects. I mean, I'm talking about the kind here. The kind will be of Kubernetes kind will be. These are two things that you need to think about storage. So just doing logical comparison. So this will require for a storage, and we also saw for networking. Right? The networking, since we're discussing about storage, we also know it is a service. Different service type load balancer or type cluster IP. So this is covering the networking part of a typical application. But when it comes to storage, you need to use the persistent volume and persistent claim. So these are two things that you need to know from Kubernetes perspective. So this use case is primarily making use of the persistent disk. So basically, the use cases we are trying to deploy a WordPress application. WordPress is something like a blog site, right? So you can create a website or create a blog. So it's a sample. It's a typical custom content management site. So we're trying to deploy a WordPress it's an open source stuff on GKE, and for that we need a storage also. So the storage is a Cloud SQL. Cloud SQL is nothing but an RDBMS, managed RDBMS from Google. So similar to RDS, if you know AWS, it is a cloud is an RDS equivalent. So you can have Cloud SQL supports like Postgres, MySQL, all the popular stuff. So it's a managed database from Google. So basically now we are going to a component where UI is talking to the persistent DB, so the RDBMS. So that is the concept that we are going to now go. But the RDBMS is Redis is not a problem. Once you restart, the data is gone. So that's the previous use case. But this is a proper requires the data when the pod crashes, and once it is back, fetch the data from the last one. So that is a use case, and yeah, we are going to use MySQL as our DB here. So and the Postgres, the WordPress uses MySQL as a backend component, even in the open source world. So we're going to use MySQL again. Managed MySQL is Cloud SQL. So it's a terminology for Google. Okay, so in this process, yeah, so these are the persistent volume and persistent claim is what we're going to create. The persistent volume is just a representation of storage volume in a cluster that is provisioned by an admin or dynamically provisioned by the Kubernetes to fulfill a request made in PVC. So basically, PVC, persistent volume claims, is basically you need to put a request first to Kubernetes saying I need this much of storage. So the request of storage is what is called PVC, the persistent volume claim. Basically, we're claiming that I need this much of storage, and that the claim request will be processed by the volumes, persistent volume PV. The request will be processed by the PV. Yeah, so yeah, and here the storage. So there are various types of storages available, or these persistent volumes and persistent claims. They support various types of storage. And if you take storage layer, right? So storage could be a lot of variations in storage, right? So you can use an NFS mount. Could be one storage. It could be your EBS elastic block storage. Could be a variation. So various types of storage I'm talking about. So it could be your S3, could be a storage. I'm just giving S3 as an idea. So the bucket S3 simple storage. So your bucket storage could be one option. So likewise, a lot of variations are there in the database and in the storage itself. So it could be even a file, EFS, for example, and just elastic file system. So block storage, it could be a S3 storage, it could be a file storage, it could be NFS, it could be anything. So there are a lot of variations in the storage. So this persistent volumes and claims in Kubernetes, they support multiple storage options. And in fact, this was a very latest entry and very popular now. So these two aspects, because still I think I'm not very sure about the version, but I think it is still this is introduced from 1.8 Kubernetes onwards. Prior to 1.8, this storage concept is not there in Kubernetes. So and now we are in 1.18. Latest is around 1.18 or 1.19. So yeah, so the last 10 versions back, which is less than 1 year now. So less than 1 year is what the storage concept itself was introduced in Kubernetes. So yeah, so in this storage, something called storage class. So what are these things? These are various storage classes that you can mention. What type of storage class you need? You need an EBS volume or a S3 or EFS, or what type of storage you need. So that is what is mentioned in the storage class. So as part of your PVC, when you're actually doing a request, here you mention your storage class. What type of storage class you need. So, and accordingly, Kubernetes will handle create storage for you. PVs and are independent of pods, the lifecycle and preserve data through restarting, rescheduling, and even deleting the pods. So the lifecycle of a storage is completely managed by the Kubernetes. You need to take care of headache. When the lifecycle something goes down, bringing it back, for saving the state and then restoring the state. So all those is all handled by the Kubernetes. You don't need to worry about it. Yeah. So in for this use case, so we are going to use persistent disk. Persistent disk is equivalent to EBS in AWS terminology. It is EBS. So you're associating a block storage. Again, persistent disk is a product within Google, which gives you is equivalent to EBS in AWS. So yeah, we're going to use this as our storage now. So. Right. So yeah, in this process, the logical steps would be to create a GKE cluster. So that's standard, and then we create a PV, persistent volume and persistent volume claim, and storage class is the persistent disk. And of course, you need a DB, which is a MySQL. Again, the persistent disk, the product name in Google is Google Cloud SQL. So in Cloud SQL, you create a MySQL instance, similar to RDS in AWS. And then you deploy a WordPress application, and of course, you set up a WordPress blog. So basically, WordPress is the front end, and it uses MySQL as a back end. And of course, in the process, so for this MySQL, it will use this persistent volume to create the disk where this MySQL will be installed. So yeah, so this process, of course, the standard steps, you will create an environment. So of course, you do it once, export the project ready so that you can use the project ready. Git clone, and of course, you download this. And the same samples, we have WordPress persistent disk. So let's go to that. WordPress persistent. WordPress persistent disk. So here, first we'll go through that. We'll come back here. So here was setting the working directory as a current directory. Yeah, and then here we are actually standard stuff. We are these are gcloud commands. You're creating a container with a cluster name, and cluster name here is persistent disk recovery, and you're using the dollar value here. So you're creating cluster name with this earlier. Remember we used it here in the previous example. We used guestbook. So here the cluster name is persistent disk recovery. And num nodes is equal to 3, so we are creating 3 nodes, and enable auto upgrade, which means we are giving instructions to upgrade the Kubernetes version automatically. So when there's a new version, it will be automatically, the nodes will be automatically upgraded with the new version. No enable basic auth. Yeah, we're not enabling the auth. No issues client certificate. We're asking not to issue client certificate. In the previous command, if you remember, we for the guestbook example, we didn't mention this is the gcloud create command. Yeah, if you remember, this is the simplest command that we used. We just mentioned num nodes. That's all. But here you are now giving some additional inputs, not just num nodes. We are also giving additional parameters, configuration parameters, not to issue client certificate, which means for security reasons we don't want to create a client certificate from Google, but probably you can use your own certificate. Enable IPA alias, and of course disable legacy endpoints. So these are some parameters that you're creating to create a cluster. So this cluster name is created with this name. So now first thing is we need to create a persistent volume and persistent volume claim, which is backed by this persistent disk, which is the EBS equivalent. So here the GK has a default storage class resource installed and lets you to dynamically provision the persistent volume backed by persistent disk. And for example, volume claim.yaml is what you're going to use. So volume claim YAML, probably let's open that here. Volume claim. Yeah. Okay. So that's all. So simple PVC, but kind is persistent volume claim. And here what you're telling is your version is, of course, metadata is all there. So the spec, you're asking to create a access mode, which is the read-write ones. So so this is access mode. There are a lot of access modes are there. So yeah, by default we are giving the read-write, and then we are asking to create a storage of type 200 GB. So gigabyte. So yeah. So So this is a storage requirement. Basically, you're requesting at this point. It's not created yet. So you're requesting when you run this YAML file, you're basically requesting Kubernetes to saying that I need 200 GB of storage to be created. So that is the requirement that you're getting here. Yeah. So we can again same thing, apply -f, you will run it. So this manifest file creates 200 GB of storage space. Yeah, and the storage class has not been defined in the file. So PVC uses the default storage class um, resource PV backed by the persistent disk. So since we're not mentioning here the type, so by default it takes Google's standard, which is persistent disk. Google's default is persistent disk, so it will make use of that. And so when you do a get, so you can see that this volume is created with the details. So status is home, which means it is the Kubernetes accepted your request. Then the next thing is you will now you need to create a DB component because now we have storage requirement. So storage is now bound. 200 GB is available now, which is you can do a write on this. Now you can create your DB. Gcloud again, I think Kubernetes is Gcloud SQL instance, create an instance name, which is MySQL WordPress instance. And we're exporting that instance so you can get the connection name which you can use here. So now Gcloud SQL databases create Word. I'm just creating a DB now, DB name, which is WordPress, and instance is this instance that we got from this connection name. And also setting the password for setting a random password with the open SSL random command with basics for encoding. So you can use that password here. So this is basically creating the users. The database created. Now you are creating a user ID and password for this database. So using host name and password is this the random example password. So now we have a DB and we have a DB name WordPress, MySQL DB name WordPress, and user ID and password is what are you set. So now first deploying the WordPress. Now we're done with the backend. So we are now going to deploy the front end, which is the WordPress. WordPress here, same. The first thing is you also need to get WordPress to access MySQL. So you need to approve the access that front end can talk to backend. So the backend is the Cloud SQL, which is nothing but MySQL now. Yes, this Cloud SQL you need to give the access permission. So IAM, now IAM is creating a service, create a service account. So anything you need to create a service account and allow permission to access the backend. So you're giving the permission, IAM permission, by creating a service account with the service name as Cloud SQL proxy, and display name is this same. So and then also add a service account email address as an uncommented variable. So of course here you're listing the service accounts and taking the email ID from that. So that will give you the email. Choosing if I use my email ID that I use for Google login. So that will be coming here. So now adding client SQL, so Cloud SQL.client role. You need to create a service account. You need to create a role to that. So again, these are all standard IAM stuff, which is standard for any DBs that you create. Nothing to do with Kubernetes here. So you're creating IAM policy. You need to create a policy, and also you're giving a role. So for this email, it is service account that you created. Basically, you are authorizing the user ID to talk to the DB. So standard IAM stuff. So and then create a key for the service account. Yeah. So if you look at what we use now is now at this point we get a key. So the output that you get is a keys for this service account key. So you'll use that key as another Kubernetes called Kubernetes secret. So now we're talking about a third component in Kubernetes. A third component in Kubernetes. So far we saw persistent volume, persistent claim. But let's say you want to store your secrets. Secrets is one under Kubernetes object. So yeah. So here a Kubernetes secret is what we need to create. So you can use this Kubernetes special command. So Kubernetes create secret, and it is like a vault, like where you're storing your password in the vault. So you're storing your username and your password in this vault, which is a secret. Um, so now whenever you want to use uh, this one-time password that you're storing it, so after that you will not be able to see the password. So it is stored in a secret in Kubernetes. So whenever you want to retrieve this value, so you need to also you need to create a secret for the service account credentials. So you need to create secret and followed by this instance and also the key JSON that you got downloaded from the service account. So that's how you link these two. The secret service account you're linking and you're giving permission for service account to access this password. So these are the steps that you created. So basically now at this point we have a MySQL DB is created and also you have all the service account is created and the service account is you also create a secret and you give the permission for the service account to access the secret. So now in your code, now this one actually now deploy your front end. So the back end is ready. Now we're going to deploy the front end. Front end is your WordPress stuff. So here, of course, you are creating the, the WordPress Cloud SQL YAML. So Cloud SQL YAML. Cloud SQL. Yeah. So if you see here, yeah. So if you see here, we are now creating the WordPress UI component, which is a deployment component, and here we are telling the container part. It's typical spec will have RST, replicas, selectors, a template, and template will have MS, RST, MS, and this metadata and spec is this. So under spec is what you're defining as container. And here, if you are telling the image, container image is you're asking to download WordPress. So WordPress is your container image, which since you're not mentioning any link, download URL, so it will download it by default from Docker Hub. So it will download the Docker Hub WordPress image, and it didn't mention the version, so it will always fetch the latest version. So and also the environmental variables we need to define. So the DB host is this and DB user, WordPress DB user. WordPress will have a user ID and password which you need to create when you create WordPress instance. So for that you are giving environmental variables when you create this WordPress stuff. So host is this, user ID is this, and you're asking, you are referencing the secrets here, the secret name, secret keyref. You can use a value from which uses the secret keyref, and you're associating linking that secrets here. As the same thing, the DB credentials, you're referencing the password here. Basically, cloud DB credentials are the other Kubernetes objects which are created for DB. So, yeah, I'll come to this. So here we are using that DB credentials to refer that. So WordPress is now using the credentials here, and the WordPress is now running on 480. So the volume mounts is what we need to refer. The volume that we created should be mounted here. So that's where this volume mounts parameter will help you to do that. And also the DB part, you are asking to use. This is if you look at this is first image, container image, and this is the second one. So which is a different name, which is a Cloud SQL proxy. So there are two stuffs here. One is the WordPress component, which is the first name, and then second one is your database component. So this is Cloud SQL. So Cloud SQL proxy, and here you're asking to use this image, and also you're asking to use this credentials here. And this storage is where you're asking to use this volumes. So yeah, this is whatever volume that you created, you'll be used here. So yeah, this is a bit complex, but I think it gives a perspective of how to use a volume as part of your Kubernetes objects. So that is what we're trying to look at. Yeah. So when you do a get pod, once you create this DB, the DB is now created and running. Now also you need to expose your WordPress service. So when you run this WordPress service component, you'll get an IP associated. The WordPress is a UI component, so it is a load balancer with this external IP there. So when you invoke this external IP, it will you can access the UI of the WordPress. So yeah, how the HTTP and external IP address, you will make the UI. Yeah, so that's all. So if you look at, I mean, the steps are simple. It's more creating these YAMLs is what is important. So at the end, if you see, we ran those YAMLs, nothing else, on the Kubernetes side. So we created a DB YAML, and we created a front-end YAML, and after the service YAML, and then we ran that. So that's all. So basically, that is a high-level stuff. But the infrastructure that you need for this are the previous steps that you created. The infrastructure here is you need a DB with proper service accounts and permissions. So that is this step. And here you created the actual Cloud SQL DB, and here you created the persistent volumes. So yeah. So yeah, probably I think I'll logically break here. If you have any further questions, we can discuss. If you are okay, we can create this, or we can do it next week also.
Yeah, this is one of the complex topics. So yeah, slowly you can introduce the PV example next week again.
Yeah, yeah. Yeah, I think this PV and PVC are lot of. Probably I need to come with some theory. Probably I think I will in the next session. I will come with some slides so that I will explain these concepts first, and then we'll go to the using how to use Kubernetes objects. So, but the summary, the key takeaways, the important that we need to remember are this. Because creating the persistent volume is simple. Volume claim and volume is also simple. So what is important is you need to link these volumes. In fact, all these three kinds, for example. So volumes, volume claims, and secrets. Secrets are your DB passwords generally. But it could be your API password, anything you want to store, you don't want to expose it for developers or anyone to look at. So these three are will be embedded inside your service or your deployment. So they call it linking, and in Kubernetes you can link multiple Kubernetes objects. These are all Kubernetes objects, by the way. So there are Kubernetes objects like deployment service, or PV, PVC, secrets. There are Kubernetes objects. You can link these Kubernetes objects across by using this value from. So ref and value. So these are the two things that you use. What is that? Yeah, here if you see here, here we are using the person volume claim under volumes. So basically, when you're creating a MySQL DB, so here you can link a person volume claim here. So that is you're linking inside this deployment object, kind is equal to deployment. Mostly you'll use it in deployment. Service generally is not used, but mostly in deploy because these are you actually creating a pod. So pod, you're using MySQL pod. So when you create a deployment, so you this MySQL is where you're downloading this image, and also this MySQL when it is installing, downloading and installing, this has to be having this has to have some volume. Other, I mean, in Docker terminology or in Kubernetes terminology, storage is called as volumes, referred as volumes. So you need to associate the volume, storage volume here. So we'll link this. You're linking a deployment object inside a volume. So which means uh, uh, when you're running this deployment, you should ensure that first you run this MySQL volume first. You need to create that first, and then create the deployment. Because otherwise, deployment will fail, saying that this object is not there. So first you need to create the volume, and then you can link the volume here as far as the deployment. Okay. So yeah, so and then the secrets that you created, right? The secrets is referred by secret key ref. It's something that we implement. So secret key ref is like a reference. So you are telling the key is the MySQL and the key is the password. So basically, it will at this point it will look at the secret that you already created with this name, and it will fetch the value from there. So if you are not giving the actual password here, so right. Yes, and then volume mount is where you're telling this MySQL image. I mean, just imagine that if you don't want to have all these things, so it will be very simple. You can imagine that it's not there. You just need to have a MySQL. So and also you're creating the name. So this we know by default. But let's say if you have any argument that you want to run when you're creating this MySQL image, you can pass arguments. Basically, default authentication plugin and all these details. And environmental variables is where I mean I'll just minimize everything. You will get the high-level picture of um, what is there. It is not. This one is outside container. Container outside is volumes, but yeah, so this is the high-level containers. So containers will have image, name, plus argument is optional. All these are optional. Environment is optional. Ports you need to have. So ports we should tell what is the container port. So and also the name. So these name, image, and the ports are mandatory. So but rest of it is all optional. I mean, name is also important. Yeah. Now, let's say you're asking MySQL to use the volume that you created. So that's where this volume mounts will come. So the volume mounts will you're telling to mount this var-lib MySQL path to this container. So basically the mount is already created when you create a person volume claim. And in that is a folder called var-lib MySQL. So that path you are mounting here. So it is like mounting concept is I mean generally in Windows world it is mapping the network drive. So you can, for example, C drive, right? So you want to associate a E drive. For example, you have external hard disk. When you connect your laptop, you'll get a new drive, a D drive or F drive like this. So similar to that, I imagine this MySQL is your pod, laptop, and you're associating the newly created storage. You're associating to as a new drive to this pod. So that way you can basically whenever you're installing this MySQL, all your installations instead of storing in your laptop, it will be stored in this external hard disk. So now this external hard disk is always there. So even if your laptop crashes, your external hard disk is always running. So you always have the data. So anytime when a laptop is up back, MySQL is up back, so it can fetch the data from your persisted volume, which is like external hard disk. You can fetch the data from there and start using it. So that way your data is not lost. So yeah, I think this analogy will make it more clear. So when you create a personal volume, you are asking to buy a new hard disk, external hard disk, and whenever you're creating a container image, you're mounting that external hard disk into this. So that way, all this installation stuff is all the data usage of this MySQL, everything is stored in this volume that you create, right? So yeah, probably it's not very clear. Probably I'll explain that probably with some of the slides and content in the next session. But, hope you got some perspective here.
Yeah, that's good, man. Anybody else has anything to share? Okay, I think it's a good time to wind up and see you
Yeah,
guys next week then, right?
yeah, yeah.
Yeah. All right.
Okay, thank you. Bye bye.